This thing fires 300,000 laser pulses every second. It works in total darkness, doesn't need GPS. There's commercial systems that can do this, but they cost about 40 grand. I built this system for less than $1,000. GPS doesn't work underground, like at all. Caves, mines, parking garages, your phone is basically useless. And even outside, GPS only tells you where you went. It's just a line on the map. What I'm after is quite different. I want to capture the actual environment, full 3D models, every surface, every dimension, the complete physical space. There are companies that have figured this out. They make portable scanning systems that use SLAM, simultaneous localization and mapping. It tracks its own position while scanning everything around it. It's pretty sweet. Problem is, they're like 40 grand and they're all proprietary. You can't see how any of it works. And it's not like I could buy one of these and reverse engineer it. I don't have that kind of money. None of these companies are sharing their secret sauce, so I figured, all right, let's see how far I can get building one myself with open source tools and a way smaller budget. All right, so let me show you what we're working with. This is the Velodyne VLP-16. It's a 16 channel LiDAR. It spins internally around 600 RPM. It fires lasers in every direction and spits out about 300,000 points every single second. I found this one used on eBay for around 400 bucks. Retail, they're about 8 grand, or they were. This is the IMU. What I'm using here is the Wheeltech N100. It measures acceleration and rotation about 400 times per second. This is how the system knows which way is up and how it's moving in between every single LiDAR scan. I'll do a whole video on why IMU quality matters way more than I thought. The brain here is a Raspberry Pi 5 running ROS2. It talks to the LiDAR, the IMU, and records data for the SLAM algorithm. It logs everything. It's basically the central nervous system. And this is what makes it different from just slapping a LiDAR to a backpack. It's a rotating platform, a gimbal motor, and a teensy microcontroller that spins the entire LiDAR on a second axis. That's how you get full 360-degree coverage instead of just a horizontal slice. I'll break down the whole motor control setup in its own video. You know, all in, we're looking at a little less than $1,000 on all of this, but way too many hours put in. So why spin it? Here's the deal. The VLP-16 lasers are stacked vertically, but they only cover about 30 degrees. So when it's sitting still, you get this ring of data around the sensor. Great for a self-driving car that's always moving forward, but not so great if you're standing in a cave trying to map the ceiling. If you rotate the whole unit on a second axis, now the 16 beams sweep through every angle. Ceiling, floor, walls, everything. Full volumetric coverage from a single position. That's the whole idea. Simple in concept, but getting it to actually work, that took me a minute. I'll get into the details in the rotating platform video later on. Over the next few videos, I'll go a little bit deeper into each piece. I'll break down how the LiDAR actually works, what it sees, what it doesn't see, and why the VLP-16 specifically. I'll cover the Raspberry Pi and ROS2 setup, how all the pieces talk to each other. The rotating platform gets its own video. Motor selection, simple FOC, the teensy, and all the mechanical stuff I had to figure out. And then SLAM, how fast Leo takes all this raw sensor data and turns it into a map while tracking position in real time. If you want to follow along, hit subscribe. See you in the next one.